and welcome to this Facet video on graphing data from the MQGem product MQEV. This video will cover the benefits of graphing your accounting and statistics data, with examples to demonstrate this. The accounting and statistics data that an IBM MQ queue manager emits can tell you a lot about how your queues are being used. Sometimes the best way to view that data is not by looking at lists of numbers, but instead by looking at the data in a graph. Graphing data can be useful for numerous reasons: trend analysis, problem determination, and management summaries. MQEV collects the accounting and statistics data and will respond to commands to display that data. In other videos, you have seen both MO71 and MQSCX display the output of such commands. MO71 also has the capacity to graph data from MQEV. The same commands are used by MO71 to create the graphs that it used to display the data in a list, but with a couple of different options. MQEV commands are designed to help make the data more easily graphable. Application data can be gappy. If the application only runs from 9 AM till 12 noon each day, then there will be no data in the afternoon. When making a graph, it would be misleading to create a line graph like this, and instead it would be better to have data points conveying 0 for the gaps. MQEV provides this facility using an attribute called gap fill. There is also an attribute called zero vals, which is used to show or hide counts that are 0. It is useful to hide them when you are viewing data in a list, but it is essential to show them when making a graph. With these two options on the commands it sends to MQEV, MO71 can create graphs with the returned data. Let's take a look at some example graphs that demonstrate trend analysis. In our first example, we take a look at the overall MQI statistics for our queue manager. Our statistics data was emitted every 30 minutes by the queue manager, but we are going to graph it using an interval of 1 day and have MQEV total it up for us. This totaling happens because of the interval we select, and is yet another way the MQEV commands are designed to make graphing the numbers easier. We're going to graph the number of messages being put as a good measure of how much work the queue manager is being asked to do. We can see from the graph that the work this queue manager is doing is gradually increasing over time. This doesn't tell the whole story though. When we add the non-persistent versus persistent messages to the graph, we can see that the proportion of persistent messages is reducing even while the overall number of messages being put is increasing. A bigger proportion of the messages are now non-persistent. In our second example, we take a look at the queue accounting data for a specific queue on our queue manager in a graph that we saved earlier. This data is summed by application name, pulling together many different records for each run of these various applications. Summing the data by different factors is another way the MQEV commands are designed to make graphing the numbers easier. We can see, looking at the height of the total of the stacks, that the overall number of messages put to this queue started increasing at this point, which was when the web order application went live for a subset of customers to use. And then later there's another increase, which was when the web order application was generally available for everyone to use. This doesn't tell the whole story though. Looking at each of the individual stacks, we can see that when the web order application came online, the mail order application started reducing quite markedly, and all the others reduced a little bit. To see that reduction more clearly, we switch to a line graph. We can see the mail order and reseller applications took an early reduction when the web order application came online, and later, as the web order application ramped up, the application that handles the Eastern Region retail took a dip, as well as the mail order application, tending towards 0. Over time, the web orders application increased to be the largest user of this order input queue. In summary, MQEV collects and stores IBM MQ accounting and statistics data. MQEV can provide the numbers to graphing applications such as MO71, with summing, gap filling, and zero values shown as required. Graphing your accounting and statistics data makes it very easy to see trends and understand the usage patterns of applications. Graphing can also help with problem diagnosis and summarizing your usage to describe to other people. This concludes our video on graphing data in MQEV. You can see there are many benefits to graphing your accounting and statistics data. If you have any questions or comments about this video or the product, or would like to be sent a trial license so you can try it out for yourself, then please send an email to support@mqgem.com. Thank you for watching.